All right, parallel lines. Parallel lines, we should already have a concept of this, but parallel lines are just lines that never intersect. And really, they're coplanar lines that never intersect. If they're not on the same plane and they don't intersect, we call them skew lines, but we typically don't get those things confused. And parallel lines do have a lot of applications. And so we're going to kind of look at this first from the algebra perspective and then from the geometry perspective, okay? If you recall from algebra, and we're not going to do a whole lot with this, but if you recall from algebra, parallel lines are lines that had the same slope. And that idea of slope, the slope kind of measures the steepness of the line. It kind of shows us the shape or the pattern at which this thing goes off on an angle. All right. And so when we translate that to geometry, we translate it into simply having the same angle. All right. And so when you kind of think about it, the thing that makes parallel lines parallel is that they kind of head in the same direction, but they're not on top of each other. Okay. And that idea of them having the same slope, the same steepness, is the same as the idea of them having the same angle. Okay. So these lines head off in the same direction, the same angle as we look at them. All right. And so when we look at parallel lines, we label parallel lines based with these little kind of arrows on them. And so if each of these lines has the same number of arrows on them, it means that they're parallel. So if I were to put a second set on here, now these lines aren't parallel, but now I'm marking them as parallel, okay? So we use this little quick notation to just say, hey, these are parallel, and I show that by putting the same number of little arrows on each line, okay? And again, these are parallel because they're kind of showing us the same angle. These each have an angle measurement of 0 in terms of looking at the angle at which they head off. And if we look at another example here, I want to determine if the lines are parallel. And so here's what I'm going to do. I'm going to kind of take this protractor. Let me scoot it out of the way for a second here. I need something to measure these lines off of. If I kind of scoot this one off to the side. Sorry, I scooted my whole paper a little bit. And if I kind of scoot that off to the side, what I want to do here is I want to get a base for this thing. And so I need somewhere to start. And so like on this one, I might draw like a line right here. And I probably should have used a different color so I don't get it confused with the lines I'm dealing with. But if I kind of start with a baseline here, and I'm using that because I have this kind of on lined paper. But if I measure each of those angles based on this green line that I've drawn, if they're parallel, they should both go off at the same angle. And so the idea here is determining parallel lines is just a matter of measuring these from the same perspective. And so this one, if I grab my protractor and kind of scoot it over here, and so here if I look at this guy, sorry, that's not very good. So I'm trying to get it lined up pretty nicely. There we go. I'll just do it like that. So I'll just measure just below. And it's okay as long as I measure from the same spot on the other one. But I look at this thing, and it looks like I essentially have a... I'm measuring on the inside track. It looks like a 65-degree angle. And so when I look at this thing is headed off at a 65-degree angle for this first one. Okay? But now let's scoot it over and measure the second one. Or the first one, I guess this one is. All right. And again, let me kind of adjust this thing just a little bit. Oh, there we go. This one I can drop on there pretty exactly. And so as I look at this thing, it looks like this measures a 62-degree angle. And so when I compare those, these are not headed off at the same angle. All right. And so when I look at this guy was heading off at a 65-degree angle, and this guy is heading off at a 62-degree angle. And so because they're not heading off in the same direction at the same angle, what happens is this guy's going to get closer and closer to this guy as they go, all right, because the angles aren't the same. If those angles are identical, then they'll keep going off forever without ever intersecting one another, okay? And it's that idea of, do they have the same slope? But in geometry, we think about, do they go off at the same angle? And these ones don't, so these are not parallel lines, okay? So this pair is not parallel. And the symbol we use for parallel when we're talking about these things is just a little set of parallel lines, okay? The other way you could write not parallel is you could draw a set of parallel lines and put a slash through it for not parallel. But that gets a little bit confusing because of all the little lines that we have in there, okay? It might be hard to read, okay? If I look at the next one, same kind of thing. And if I kind of use just a baseline here for this guy, and it doesn't really matter if I get exactly on this line because really I'm measuring from a horizontal line no matter where I put this protractor at this point, okay? And so if I look at this thing, it looks like this thing heads off at looks like a 34-degree angle for the second one. And so if I scoot this guy over and measure the first line, and so putting that guy right on the line, it looks like this is also a 34-degree angle. I can kind of see it right here. And again, I'm measuring using the inside track, so that's 34 degrees. So I have to kind of count those little tick marks. But each of these has the same angle. And so the idea, just like having the same slope, if they go off at the same angle, it's the same concept as having the same slope. But that just means that these things are parallel lines, okay? So each of these, if I were to measure off of a horizontal line, had a 34-degree angle. And so if the angle is the same, if they go off at the same angle, it means these things are parallel, okay? So I'm going to say, yes, these are parallel lines. Okay, that's it.